Hi everyone, this is Ali. Welcome to another episode of RPG Core. In previous episode, if you recall, black screen. If you recall, my character was not able to fix the problem of going below the water, and at the end I sent a comment that I found the solution for that. The solution for that comes into Edit Project Setting Time. Fixed time step is what is defining the fixed update interval. It says that every 0.02 seconds we will call one fixed time step. So if I increase the number, like for 0.2, I will make everything worse. Even my character will drop to the bottom of the ocean on the floor. So I went on the opposite direction and I set it to 0.01. Okay? If I play now, come on. Oh, manager. Player spawn water. I made two player spawners, one on top of the water, one on the shore. Anyway, as you can see, now my character is fixed and it's in the proper position completely. Okay, now remember that using edit project setting time like this is a huge performance hit, and you lose lots of performance boost because now we are calling every fixed update very fast. But if you are targeting PC games, Xbox and PlayStation, this shouldn't be a problem. On mobile games though, you may want to come back and change this number to its default of 0.02. Anyway, now today I told you that I'm gonna get rid of this guy. So first of all, let's nuke it. Delete. Now, didn't I said delete? Yeah. First of all, I want a enum class, and I will call that enums. I will put every enum of the game in this class, and I will pay no attention to the class construction itself. We don't need namespace. Okay, our first enum will be public enum Gizmo types, and we will call them box, sphere, circle, arrows, direction, anchor, text, and none. Another one, public enum point behaviors. We start with none, then we go with player spawner or player spawn, then enemy spawn, NPC spawn, and anchor and waypoint. Okay, then we will start another script and I will put it on helpers. This is a monoscript. We call it Gizmos, debug Gizmos. Debug Gizmos. We will have lots of public variables, public Gizmo types, and we call it Gizmo type. Next one is public point behaviors. We call it point behavior. Next is public float Gizmo size equals to 1. The next one will be what was that? Radius. Okay, public float radius equals to 1. Next one is public float point sphere radius, and this is equals to 0.5f. Next one is public vector tree direction equals to vector tree dot 0. Next one is public, again, vector tree size equals to vector tree dot 0, and public vector tree icon offset equals to vector tree dot 0. Next one is public not 0, it's new vector tree 0, 4, 0. Next one is int angle, public int sections equals to 3. Next one is public string text equals to string dot empty. Next one is public string icon equals to string dot empty. Then we will have some booleans. Public bool draw boundings equals to true. Then public not partial, public bool bool draw camera, and it's default to false. Public bool draw volumetric equals to true. Public bool draw texture equals to true. Then public bool draw point sphere equals true. Then public bool get external radius and get external angle, get external size, get external direction, and get external text. Then we will say public bool use local matrix, and we call it equals true. Then we say public color outline equals to color dot black. Public color Gizmo line equals to color dot yellow. Public color text color equals to color dot magenta. Public color extra equals to color dot blue. And finally public color volumetric equals to new color of 0, 1, 0, 0.3f. Okay, these are our public variables. We will have some some public what was that? Properties, public float external radius, get and set. Another, this time int external angle. This one is vector3 external size. Another vector3 external direction. Then this one is string and it's external text. And finally public transform my transform and get and set. One private variable. The private variable will be private color, and this color is point sphere color equals to new color of 0.01f. Now, in methods, in a start method, first of all, we say my transform equals to transform. Then we say game object dot layer equals to layer mask dot name to layer of ignore raycast. And then we say if game object dot collider, then we say game object dot collider dot is trigger equals to true. And this way I will make every game object that has this Gizmo on himself being a triggered geometry. In update, we say if get external angle, then we say angle equals to external angle. Then we say if get external direction, We say direction equals to external direction. If get external radius, then we say radius equals to external radius. If get external size, then we say size equals to external size. And finally, if get external text, we say text equals to external text. Okay? Finally, the biggest method here, we don't need this, so I will use it on draw Gizmos. Okay, all the magic is happening here. We say if not enabled, return. Then we say color temp equals to Gizmos dot color. Then we say matrix 4 by 4 mat equals to Gizmos dot matrix. Now we start a switch. The thing that we want is Gizmo type, and we say first case is anchor break, second case is arrows break, next case is box break, next case is circle break, next case is direction break, next case is sphere break, next case is text break, and final case none. We have nothing, so we break here. Okay, after all of these, we will come back to this. We say if point sphere, then we say first Gizmos, and I will capture it. Gizmos dot color equals to point sphere color, and we say Gizmos dot draw sphere from transform dot position with the size of point sphere radius multiplied by Gizmo size. Now we say if draw bindings, we will do some stuff, and we say if draw camera and get component of camera, we will do some stuff. We say if draw texture and not string dot is null or empty. The string we are looking at is icon. We will do stuff. We say if behavior is equals to no, what did we call it? Point behavior, huh? Okay. So we say if point behavior equals to player spawn, or point behavior is equals to enemy spawn, or point behavior is equals to npc spawn. Then we will do some stuff. At the end we say gizmos.color equals the color that we captured before. This is the skeleton. Now let's do stuff. So first one is the anchor. In the anchor, you say, let me move these guys a bit, PL, okay. And in here we say gizmos.color equals to outline first. Then we say gizmo.draw wire sphere from transform the position with gizmo size. Why is it not happy? Okay, sorry. Then we say gizmos.color equals to outline again. We are in outline, we don't need that. Okay, we say gizmos.draw array from transform.position, comma, transform.forward multiplied by gizmo size multiplied by 2. Then we say gizmos.color equals to extra. Then we say gizmo.draw array again from transform.position toward transform.up multiplied by gizmo size multiplied by 2. Then we say gizmos.color equals to gizmo line, and we start drawing ray after ray. First one is right. We change the gizmos.color, gizmos.color equals to I don't like it, but I will use it anyway. Text color. I will tell you why I didn't like it anyway. And you say again gizmo draw array from negative up, then negative right, and finally negative forward. So we are drawing to the left, to the down, and to the back. And when I'm drawing extra, I will say gizmos dot draw line from transform dot position minus transform dot forward multiplied by 0.1 f multiplied by gizmo size toward transform dot position minus transform dot forward multiplied by 0.1 f multiplied by gizmo size, but we add transform dot right transform dot right multiplied by 0.4 f multiplied by gizmo size multiplied by 2. This is one of our guidelines, if you recall from anchors. We get it again, So we are still going forward. We are still going forward, but here we go to the minus right. At the end of the drawings, we say if draw volumetrics. Then we say first gizmos dot color equals to volumetrics. Then we say gizmos dot draw sphere from transform the position with radius multiplied by gizmo size. This is not the radius I wanted. Radius, yeah, this is the radius I wanted. Okay, so this is the anchor. We go for the arrow. I will copy paste the arrow because, as you recall, I got it from a wiki. It's the same code. We first set the gizmo to blue, then draw an arrow toward the front. We set to the green, we draw a gizmo to the up, then to the red, and we draw to the right. Box. In box we say, no, gizmos dot color equals to gizmo line. We say gizmos dot draw wire cube from transform the position with the size we gave it multiplied by gizmo size. At the end we say if draw volumetric. We say gizmos.color equals to volumetrics. Then we say gizmo, gizmo.draw, this time cube, from transform the position toward size with the size multiplied with gizmo size. Okay, this is the box. If we are going for the direction, we are not doing anything in here. If we are drawing circle, do I have it here? No. I removed it from here, so I add the method again. Then we will see what it's doing. We have a method called draw circle that gets a center, a radius, a segments, rotation, and color. We do a sanity check so that segments don't go below 3. Then we convert the rotation to the radiant. We start a loop and we get the angles, we get the points, we draw lines to the point with debug.drawLine. Okay, so when we are using debug.drawLine, it means that on top of our class we need to add something. We need to add execute in edit mode. Okay, now in here, when we are drawing the circle, we say helpers dot draw circle from transform dot position, this is the center, with the radius we have and with the sections we set, with the angles we gave for the rotation, with the color of gizmo line. Next one is a sphere. In a sphere, we say Gizmos dot draw dot color, sorry, equals to Gizmo line. Then we say Gizmos dot draw wire sphere from transform that position with the radius we have multiplied by Gizmo size. Then we say if we want the volumetric, first change the color to volumetric, and then we say Gizmos dot draw sphere from transform that position with the radius multiplied by Gizmo size. We don't do anything for the text here, and that's that part. For the camera, we no, the bindings, sorry, the bindings, we say if two different things, I think. No, okay. We say if get component mesh filter does not equal to null, or game object dot collider does not equal to null. So if we have a mesh renderer or if we have a bonding, we do this. First we say Gizmos dot color equals to outline. Then we say if get component sphere collider does not equal to null. We check if the collider type is the sphere, sorry, is equal to null. So if any kind of collider we have that is not null, if any collider we have that is not sphere, or we have a mesh filter, then we say var bounds equal to get component mesh filter. If this condition is true, then the bounds is get component mesh filter dot shared mesh dot bounds. If this is not true, then we don't have mesh filter, we go for game object dot collider dot bound. After that, we say if use local matrix, we say Gizmos dot matrix equals to transform dot local to var matrix. After that, we say if draw volumetric I'm forgetting something, but anyway, if draw volumetric, then we say Gizmos dot color equals to volumetric, and we say Gizmos dot draw cube from bounds dot center comma bounds dot size. Okay, we get this line before volumetrics, we add it here, but instead of draw cube, we want draw wire cube with the same stuff, but we say, we set the color before. Okay, and finally after that we say gizmos dot matrix. Why don't you get it? Matrix equals the mat we calculated before. Now if we have a sphere collider, this won't show properly, so we say gizmos dot draw wire sphere, and that is from transform dot position, comma, get component of sphere collider dot radius, and here we say if draw volumetrics, again we capture the color, then we say all of this, but instead of wire we draw the sphere. Okay, now on helper I need another class that is called public static vector3 as return plan 3 intersect. What we want is a plan P1, a plan P2, a plan P3. Then we say return of minus P1 dot distance multiplied by vector3 dot cross of P2 dot normal comma P3 dot normal plus minus P2 dot distance multiplied by, again, pretty much the same thing, but here we get, why are you, okay, P3 and P1, and finally plus same code, but here is P3 with P1 and P2. So what we are doing is getting the intersection point of 3 different plans. Okay, after all this calculation we divide it by vector3 dot of P1 comma P1 dot normal comma vector3 dot cross of P2 dot normal and P3 dot normal. This is crazy math, but you can find all of it in the mathematical websites anyway. So going back to debug Gizmo, why did we need all that crazy stuff? Is for drawing the camera. Every one of the camera Gizmo drawings that I saw outside wouldn't draw it properly. So we say vector3 array of near corners equals to new vector tree of 4 points. Okay, same thing for far corners. Then we say plane array of camera planes equals to geometry utility dot calculate frustum planes of get component of camera. Okay, then we say plane temp come on equals to cam plane of index of 1, and then the same code, but we say cam plane 1 equals to index of 2. So we are doing a sweep here, and finally the 2 delete, okay, and 2 equals to temp. Okay, so we've done a bit of switching, and then we go for a for loop of I equals 0 to I less than 4, I plus plus. We say near corner of I equals to our class that we calculated of cam planes index of 4, comma cam planes index of I, comma cam planes index of I plus 1 modulus 4. Okay, so what we are doing is getting near corners on the created projection matrix. Then we pretty much do some calculations like this. We say far corner, but here we start with 5, then going to I, everything the same, and this is the far corners on the created projection matrix. Okay, after this array, this loop, we go for another loop of again I less than 4. We say that debug dot draw line of near corners of I to near corners of I, I plus 1 modulus 4, and the outline color, and then we say duration is time dot delta time, and finally depth test is true, so we will not see it if it is going below any geometry. Some lines of code from far corner I plus 1 modulus 4 with outline, everything is the same. And finally we say another from near corner I to the far corners of I, but here we use Gizmo line as our drawing, and that's it. We draw the frustum. If we are going to draw the camera, the texture, we say Gizmos dot draw icon from transform dot position plus icon offset and the icon we are going to draw is icon. Then we say Gizmos. No, Gizmos.color equals to new color outline R green and blue, but the alpha is 0.3f. And we say Gizmos.draw line from transform dot position toward the transform dot position plus icon offset. And that's the drawing of the texture with the line toward it. Finally, we say if we are spawning player, enemy, or NPC on this position, I want another circle from transform the position with the radius of 0.4 f, the sections of 24, and the rotation of 0 with Gizmo line as color. Okay, this will indicate the exact position and the size of the character that will come in the scene. And by that, we finish this script. Holy cow, that was a big script there. Of course, now we will remove this component. I will add a debug. What the? Oh, come on. Come on, debug Gizmos. This is a mess. I want a sphere. This is player spawner, and this is what you get. Okay. And remember, I need to remove this guy. And this is what I get. Gizmo line. This is the player, so I will go with that. And the volumetric, I can reduce the alpha so that it gets more transparent. Now we lost the arrows, but I can add another one. This one will be arrows and the behavior will be none. Okay, and that's it. And I can even make it a bigger one, or I will go with one. I like this. Now in here, not here, but in projects, we need a new folder called Gizmos. In Gizmos, I will add some images that I got from a pack, but I tweaked it a bit. All of them is alpha transparent. Apply. Okay, this is the player, so I will go with humanoid green. Get the name. Coming here, we say draw texture, and the icon is this guy. Okay, and you see that I get an icon there, so this is a player. Let's get to this guy. We don't need this, we don't need control point. We add a debug Gizmo. It's a player spawner and it's sphere. I will add another one that is arrows and none. Okay, so I get this, but let's call this NPC, whatever. So this is NPC. For the NPC, I will go with what? Humanoid yellow. In here, I will add the name to the icon, and let's call back a bit. And you see that as soon as I add the name, the icon will appear. Okay, and there we go. So if I now look at the icons here, I can say, okay, this is an NPC, this is the player, and if I duplicate it, move it to the side, and use not animal red, and I can say that this is an enemy spawner, for example. Okay, and here the behavior is, of course, enemy spawn. This guy is NPC spawn. Okay, by itself the point behavior will do nothing. Okay, but in next episode I can now change all the anchors here from using our previous anchor point script to use the debug gizmo that is anchor. Okay, and oh voila, 0.5, 0.3, there we go, and the behavior now is anchor. Okay, so this is the anchor, and I can say draw volumetric. Why don't you draw the volumetric? My code is off a bit somewhere in the anchor. Ignore all. Yeah, because I'm drawing the wire sphere. Sorry. And we get a volumetric now here. Okay. Compile. Come on, compile, compile, compile. There we go. Okay. And of course I can change the colors because I want the blue, some bluish color to be the front. This guy will be right. These guys are okay. This guy will be green. And there we go. Okay, so we got our colors, and this is exactly the same object but with another behavior. Now in the code, let's do it. I have few minutes. In the code, in cliff climbing trigger, then we get in a start, okay, we say anchors equals to transform dot root, no, root, this is the top parent, dot get components in children, get components in children of debug gizmos, okay, dot, this is the link, where a delegate goes into a condition, and the delegate condition is that point behavior equals to anchor, okay, and finally to an array. And of course now I need to change the anchors to, am I right? Yeah. Okay, in here I need to change anchor point to debug gizmos. Okay, everything else should work. So this way I can check that, hey, get the component, and in the component check my behavior of the point. If it's behaving as an anchor, then add it to an anchor. Okay, of course now I should delete all these anchors and duplicate this guy. Come on, compile. Okay, so what did I do? So I duplicate, move to the side, I duplicate, move to the side, I duplicate, move to the side, duplicate, move to the side, duplicate, move to the side, duplicate, move to the side. Then select all of them, duplicate, move it to the side. Okay? And this system will behave exactly like before, but here now we have the ability to select all the anchors by this point behavior. Now later on in game, if we want to select all the player spawners, we can use something like this, but instead of transform.root.get, we can say find objects of type debug gizmos dot where the delegate goes in, and the delegate we want is point behavior equals to for example player spawner, okay, and then convert it to array. This way we will get, with this code, we will get all the player spawners inside the scene, inside our level, and easily access all of them. And now we finished a Gizmo script that first can come on top of each other, so we don't want to draw none of them again. Okay? For example, now we can have, oh wait, yeah, it's working. Okay, now we can have many of them on top of each other just for different behaviors, and we can use all of them, or I should say one script on different type of objects for just different behaviors, but with one single script. Okay, now this script is a mess. I don't like it like this. We will start doing a custom inspector GUI for this guy in next episode. One thing I want to mention is why I let you choose the local matrix or not. Sometimes on this is one good example of that. Sometimes it won't behave properly, so I will remove this component, add it, and you see that now it's behaving. Okay, now it's nicely behaving. In cliff trigger, it's behaving, but sometimes in geometries, especially if they are rotated, you see, sorry, in one direction. What the hell are you doing? Why are you doing like this? Anyway, let's duplicate this guy, move it outside and rotating it to 0. Yeah, it's behaving, but sometimes I saw that it's not behaving. Okay, sometimes you get object, but the volumetric is not drawing. In those times, you need to uncheck this guy. So sometimes you see this. Okay, where was that? Sometimes you see this. Even when the use local matrix is checked, you won't see the geometry, volumetric. Then you will need to uncheck it. Okay, so this is a reversible thing there. I'm not sure why, but sometimes it doesn't behave properly. Sometimes it behaves properly. But now, you know, I'm very happy with the result. And by this episode is finished right on 1 hour. Have fun, everybody. See you in next episode.